Hello students, in this lecture we will discuss about methods of circuit analysis. In chapter 8 there are three parts. Part 1 is introduction to current sources and solution of circuits which have current sources. In part 2 we will be discussing mesh analysis. In part 3 we will be discussing nodal analysis. So we split this chapter 8 into three parts. In this lecture we will be dealing with part 1. In part 1 we will introduce you to the current sources because we have not so far discussed about a current source. So far we have discussed only about voltage source. Then what do you mean by source conversion? Source conversion means how do we convert a current source to an equivalent voltage source, or how do we convert a voltage source to an equivalent current source. Then we'll have a brief discussion about how to solve a problem where the current sources are connected in parallel. Then we will have a discussion whether it is possible to connect current sources in series or not. So this will be the topics that will be covered in this part of the presentation. Now going to part 1. So as I told, we will be starting with current source. First we have to understand the concept of current source, because so far we have discussed only or used only a voltage source. Now in this method of analysis, we will also be discussing about mesh analysis and nodal analysis. And this current source will be very useful when we are dealing with nodal analysis. So why we have to use mesh and nodal analysis? Because there are some circuits which are neither series parallel or series parallel. For example, suppose I have a circuit like this. I have a circuit with two sources and the resistances are connected in this way. Let me draw the circuit for you. Now you have the resistance connected in this particular way. So I'm going to have three resistances and the circuit is in this way. So these are the three resistances. Now if you closely watch these resistances are not connected in series, they are not connected in parallel, or they are not connected in series parallel. So this is a circuit where you cannot use series, whatever concept that you have studied in series circuit, parallel circuit or series parallel. So the idea of using mesh and nodal analysis is, for any configuration given to you, we can apply the mesh analysis or the nodal analysis and solve the circuit. You all are aware of what do I mean by solving a circuit. Solving a circuit means finding out the current and voltage power in each and every component of the circuit is called as solving the circuit. So by using mesh analysis and nodal analysis for any given configuration, let it be series, let it be parallel, let it be series parallel, or any complicated circuit given to you, we can use this concept of mesh and nodal analysis to solve the circuit. So this is why, so when you are dealing with nodal analysis, we have to deal with current sources, and that is a reason why we are going to discuss about current sources in this chapter, in general about the sources. Now so far we have been using this source. This source is called as an ideal voltage source. Now this is a network. Now what do you mean by this network? Now let us take this configuration. Now this particular portion shown in gray color is called as the network. So we are replacing this entire resistance with a box called network, and this is the box that you find here, and this is the box that you find here. So this is called as a network, and this is called as the terminal of the voltage source, and this terminal is here. So this is the terminal of the voltage source. So the source is connected to a network. Now what do we mean by ideal voltage source? So we have to understand this word ideal. Ideal means whatever the current drawn, whatever might be the current drawn by this network, the voltage produced by the source is constant. See, whatever might be the current can be zero, current can be very high, still you find the voltage is constant and its value is E. So in order to make you understand, let me take 10 volts. So what will be the voltage? Even if the circuit, even if there is no network connected here, it will still produce 10 volts. Even if there are, if you connect a very big load which is going to draw a very big current, still this voltage will be a constant. So irrespective of the value of the current drawn by the network or the load, the voltage will remain constant. So this is called as an ideal voltage source. Now This is the first time that we are going to discuss about a current source. Now, why we have to discuss about a current source is because while you are dealing with electronic circuits, not electrical circuits, while you are dealing with electronic circuits which consist of transistors, diodes, SCRs, we will replace part of a circuit with a current source. So understanding of current source is very vital to understand the concept of electronic circuit. So a current source is represented by an arrow mark. This is called as the head of the arrow. The head of the arrow indicates the direction of the current. So our ideal current source, let us for example take it as 10 amperes. So this current source will produce 10 amperes and supply it in this direction. You can see the arrow mark is upward. So the direction of the current is it is moving upward. Then it will move into the network. So irrespective of the voltage of this network, it will produce 10 amperes. So you can see here the graph, it is constant. Whatever might be the voltage level, it can be 0, it can be any value. So the voltage across the network can be any value, but the current produced by the source is constant. It will remain constant. That is why you see a straight line. So this is called as an ideal current source. So first we have to learn the symbol of current source. For example, if I draw a current source like this and mark an arrow mark like this indicates the direction of the current source. So what does it mean? The current in this branch is flowing from left to right in this direction. So the current source indicates, the arrow mark indicates the direction of the current source. So these two sources are called ideal voltage source and ideal current source. So this is called as an ideal voltage source and this is called as an ideal current source. I hope you understand what is a network because I made it clear by drawing a box. So anything inside this box we call it as a network and we replace the network here so that we are now discussing only about the source. So what are the types of source that we have? We have many types of sources. So we have AC source and DC source. AC source is represented by this symbol, a sine wave. We are not discussing this AC source in this course. In future courses, we will be discussing about AC source. In this circuit analysis, we will be discussing only DC source. And in DC source, we can divide this into two sources. One is called as an ideal source and another one is called a practical source. So I already gave you an example of ideal source, ideal voltage source, ideal current source. So if you go back to the previous slide, you will find this is called as an ideal voltage source and this is called as an ideal current source. Now what about the other sources? Yes, we have another source which is called as a practical source. So practical source also we have two practical source. One is called practical voltage source and practical current source. Practical source means the source that you use in your lab class. The source that we use in our lab class is called as a practical source. This will be the source. It will look something like this, where these are called as the terminals. These are called as the terminal, positive terminal, negative terminal. This is the terminal of the ground. So all these things you would have seen in the lab class. Now this entire box is represented by dotted line here. So what is inside the box you cannot see. So that is represented as a dotted line and you can see the positive terminal is marked as red point. So you can see this is the positive terminal. Here this point is called the terminal. So we have access only to the terminal and we cannot do anything inside this source. So what is the difference between ideal voltage source and a practical voltage source? The difference is in an ideal voltage source, the resistance at this portion, we consider the resistance here to be 0. And whereas in a practical voltage source, the source will have a inbuilt resistance, a very small value of resistance, and RS is called source resistance. So all sources are practical sources, but for easier understanding, we approximate the practical source to ideal source only for our understanding, but there is nothing called as an ideal source. Only in this course, while we are studying the concept and learning few techniques, we use this ideal source. Ideal source means the source resistance is 0. We assume the source resistance as 0. But practical source in a real case, if you take a source like this which you have in your lab class, there will be a very small resistance. So when you have a resistance connected in series with a voltage source, then we call it as a practical voltage source. Now let us come to a current source. In an ideal current source, the parallel resistance Rp is infinite. Infinite means open circuit, which means this branch is open. So if this branch is open, then you call it as an ideal current source. But whereas in a practical current source, there will be a resistance which is connected parallel to this current source represented by Is. So here now you understand that there are two kinds of sources, ideal source and a practical source. In ideal source, we have ideal voltage source. This is ideal voltage source, and this is an ideal current source. And this one is called practical voltage source, and this one is called a practical current source. So the dotted line indicates that this part of the circuit or this part of the circuit is inside the box. We cannot see what is inside the box. We have access only to the terminals which is represented here. These are the terminals, positive terminal and negative terminal. So what is the difference between the ideal and the practical source? For example, if you make the source resistance or the series resistance as 0, if you make the series resistance as 0, you will get these characteristics. But in real time, this series resistance is not 0. There will be a small value. So depending upon the current drawn by the network, please remember that here we have our network. We already know that here we are having our network or the load. So depending upon the current drawn by the load, there will be some drop in this series resistance. So you will find that the characteristics has a slope or a slope characteristics. It's not a straight line, it is dropping down. So this would be the graph of a practical voltage source. So this would be the graph, but for understanding, what we do is we neglect the resistance and we assume that the voltage source is going to produce a constant voltage for us for understanding the concept of circuit. Similarly, in a current source, this parallel resistance we normally do not consider. We consider that to be infinite. So you will get this ideal characteristics represented by a blue color line. But in real case, this practical, there will be a small current which will be flowing through this parallel resistance, and the current I naught, this current is called as I naught. So what will happen? This current source will produce a current, for example, let us say 5 amperes. If it produces 5 amperes current, and let us say 1 ampere current is flowing through this branch, so what is the current which will flow through the network? All of you could answer this question very easily. So let us assume that this portion is our network. So what will be the current flowing here? 5 amperes is produced by the current source. 1 ampere flows through the branch. So the remaining 4 ampere current will flow to the network. So in an ideal circuit, 5 amperes will flow, but in a practical source, only 4 ampere. That means the current, after subtracting the current flowing through the parallel resistance, the remaining current will flow to the network. So you will find that it is a slope line. It's not a straight line. It's not in the ideal case you will get a straight line, but actual case there will be a drop in the characteristics as shown here in this graph. So this is a difference between ideal current source and a practical or a real current source. So let us go to source conversion. Now what do you mean by source conversion? Source conversion means we are going to convert. Now please understand, in this lecture we are concentrating on the source. So the source which is represented by blue color is a practical source. So you are going to convert a practical current voltage source to a current source. We can do this conversion. Now the question is, why we need to do this conversion? The answer is simple, just to make our job easy while we are solving the circuit. So what we can do is, if it is going to make our job easy, we can convert this practical voltage source into a practical current source, and we can do the same. So we can convert this source into this source, we can convert it, or we can convert a current source also into a voltage source. So we will first discuss how do you convert a voltage source to a current source, and then we will discuss how do you convert a current source to a voltage source. Now all of you know that this blue color region represented here, is a practical voltage source. You have a source and you have a series resistance. You have a series resistance. And these are the terminals of the source. Across the terminal here, for very simple analysis, we consider that there is a load which is represented by the resistance RL. Now this is the source. Now I want to replace, or I want to convert this voltage source into a current source. How do I convert? So voltage source in series with the resistance is converted into a current source with a parallel resistance. So again I repeat, voltage source in series with the resistance is converted into a current source with a parallel resistance. Now, why do you put the arrow mark in the upward direction? Because you find this minus and plus. So the arrow mark should be in this direction. So the direction of the current source is determined by the polarity of the voltage shown here. So here the current is in the upward direction, and this resistance whatever here, it will be converted to a parallel resistance. Now we will do the reverse. I want to convert the current source into a voltage source. How do I convert? So a current source with a parallel resistance can be converted into a voltage source with a series resistance. So this way of converting a current source to a voltage source and vice versa is called as source conversion. It's called as source conversion. But there is one important thing that you have to understand. The ideal sources, we cannot do source conversion for ideal sources. Again, I'll go back to the previous slide. So here you see that you have an ideal source. Ideal voltage source cannot be converted. This is not possible. You cannot convert ideal voltage source, or you cannot convert ideal current. So this is not possible. But you can convert a practical voltage source to a practical current source, or a practical current source to a practical voltage source. This is possible, whereas you cannot do current conversion with the ideal source. So this you have to keep in mind. Now, while you do the source conversion, to make it easy for you to understand, let us take some value. So that let us assume that the value of the source given here is 10 volts and the resistance is 2 ohms. And I want to do source conversion. How do I do source conversion? First thing that you have to understand is how to mark this arrow mark. Please remember, this arrow head of the arrow should point towards the positive polarity. So here the arrow mark is facing in the upward direction. And what is the value of this current? So let me take another color. And then the value of the current is determined by the Ohm's law. So what is the Ohm's law state? How do you find the current? Voltage by resistance. So 10 divided by 2, the current is 5 amperes. Here the current would be 5 amperes. And the resistance here, the parallel resistance is equal to the series resistance. So this will be 2 ohms. So this is how you convert. So I am teaching you how to convert a voltage source to a current source. So a current source, we have to do two things. First, we have to determine the direction of current. How to determine the direction of current? By based on the polarity of the voltage source. Then the next one is how to determine the magnitude of the current. The magnitude of the current is determined by Ohm's law. So what is Ohm's law? What is current? E divided by Rs. So 10 divided by 2, this is 5 amperes. What about the value of parallel resistance? The value of parallel resistance is equal to the value of series resistance. So what is the series resistance here? 2 ohms. So here also you have 2 ohms. Now let us do the reverse. Now what we are trying to do is we are trying to convert. Let us assume. Let us try to convert current source to a voltage source. So let me remove this numbers here. So now let us assume that I have the values for the current source. So we are going to do the reverse. Now let us assume that I have the values of the current source. So let me take a color. Okay. Let us assume the current is 15 amperes. Let us assume the current is 15 amperes here and the resistance is 3 ohms. So how do you find the voltage here? Now this information is known. We know the value of the current source. Now we have to determine the polarity of the voltage source. How do you determine the polarity of the voltage source? Polarity means which is positive and which is negative. The polarity of the voltage source is determined by the direction of the current. So the arrow head is positive. So this point is positive and the tail of the arrow is taken as negative. And how do you determine the magnitude of the voltage? Again, Ohm's law. According to Ohm's law, the voltage is the product of resistance into current. So 15 into 3, this will be 45. So the voltage will be 45 volts here. So this is how you determine the voltage. How do you determine the resistance? As you can see from the formula, they are the same. So the resistance will be 3 ohms. So this is how you do source conversion. So we can convert a practical voltage source to a practical current source, and we can also convert a practical current source to a voltage source. Both directions we can do the conversion. Only thing that you have to remember is the Ohm's law. So again I repeat. Now practical voltage source will have a series resistance. So voltage with a series resistance can be converted to a current with a parallel resistance, or a current with a parallel resistance, current source with a parallel resistance can be converted into a voltage source with a series resistance. Now let us solve a problem. Now here this is the source. This portion represented by blue color is the source. The terminal A and B, these are the terminals of the voltage source, and the load is connected across the terminal. So this blue color box is our practical voltage source. So in this circuit, they are asking you to determine the current IL. IL means the current consumed by the load. First, in this circuit, let us determine the current. So how do you determine the current? How are these two resistors connected? They are connected in series. So what is the total resistance? 6 ohms. So if you redraw the circuit, what will happen? You will have only one source. You will have only reduce and return. You know this approach, correct? You already done it. So reduce it to only one resistance, 6 ohms. Why 6 ohms? Because these two resistors are connected in series, and the voltage is 6. So what is the current drawn by the load? Now it is very easy. Current is 6 by 6, which is 1 amperes. According to Ohm's law, voltage, which is 6, divided by resistance, which is 6. So the current will be 1 ampere. So this is how you find the current IL. So we have found the current IL, which is 1 ampere. Now what they are asking us to do in the second part of the question, they are asking us to convert the voltage source to a current source. So what you have to do is, first we have to mark the current. So the first thing is draw the current source. Now how do you draw the arrow? Remember that positive corresponds to the head of the arrow. So this will be the direction of the current source. Now how do you determine the value of this current source? Again, according to the Ohm's law, it is voltage by resistance. So 6 divided by 2, which is 3 amperes. So the value of the current source here is 3 amperes. And how do you determine the value of the parallel resistance? It is same as the series resistance. So parallel resistance is same as the series resistance. So this is Rp. So this is the resistance of the source, and this value is also same. So this is also 2 ohms. Now you have the load connected. So this is the load, which is 4 ohms. So this is our load, which is 4 ohms. So now I have converted this is the terminals. This is the terminal A and B. Now I have converted my voltage source into a current source. Now how do I determine the current? You can use the current division rule, or you can use another formula, because special formula, because here we have only two resistance. We are interested in calculating IL. So how do you calculate IL? First, what is the total current coming to this parallel resistors? The current coming to this parallel resistors is 3. So 3 multiplied by the other branch resistance. Other branch resistance is 2 ohms divided by the sum of the resistors, 4 plus 2. Again, you would have studied this in parallel circuits. So 3 into 2, 6 by 6, which is 1 ampere. So the load current is 1 ampere. So what do you know? What do you understand? We understand by converting voltage source into a current source, the current drawn by the load does not change. Here also the current is 1 ampere. When we are using the practical voltage source, we get the current drawn by the load is 1 ampere. Here we have converted the voltage source into a current source, and still we find the current drawn by the load is 1 ampere. So what do you understand? changing. The load does not know, because this is a box, so the load does not understand whether it is connected to a voltage source or a current source. It will draw the current. So it will draw the current of 1 ampere irrespective of the source conversion. So this is how you solve the problem. Anyway, I will show you how it is done here one more time. So I think you understand the question. So let me rub all these things and show you how it is done now. So yeah, let me erase it. So, yeah. So now again we will just redo this because this is our first circuit. So here you can understand how they have done the source conversion. So this blue color box, this blue color box is a practical voltage source, and this blue color box is a practical current source. So how do they convert? Voltage source with a series resistance can be converted to a current source with a parallel resistance. So I have already told you how do you get this 3 amperes and 2 ohms. And here again we are solving the problem. We understand, we already solved it. We understand that the current does not change. The current drawn by the load is always 1 ampere. Now here how do you solve this circuit? This is the first time that you come across two sources. In this circuit we have a voltage source and then we have a current source. This current source, the terminal is AB. Now how do you do this? Now convert this current source to a voltage source. Now you have to be very careful. See here the arrow mark is pointing downwards, so the plus symbol is here. Can you see this? So this is plus, this is minus. How do you find this voltage? According to Ohm's law, it is a product of current and resistance. So 4 into 3 is 12. How do you get this 12? This 12 is nothing but 4 into 3. So current source with a parallel resistance is converted into a voltage source with a series resistance. What is the value of this series resistance? Same. This value is same. So now you have this circuit. Now we have to solve this circuit. So what is the easiest way to solve this circuit? So easiest way to solve this circuit is by applying Kirchhoff's voltage law. We know this Kirchhoff's voltage law. We have used it. So we will start from one point. Let us assume that we are starting from this point. So if you are starting from this point, the current is flowing through this direction. So this point will become plus, this point will become minus, and this point will become plus because the current is flowing. They have given the direction of current in the question. So the current is going to flow in this direction. Now start from this point and apply Kirchhoff's voltage law. So what is the voltage across the resistor R2? We are moving from plus to minus. So it is a drop. So minus 2 times I2. So this is the voltage drop in resistor R2. Then minus to plus, voltage rise. What is the voltage? Plus 5. Now come to the next element, plus to minus, drop. What is the drop? Minus 3 into I2. Now go to the next element. So what is the next element? Next element is our source. Minus to plus, we are moving from minus. So plus 12. Plus 12 is equal to 0. So now we can very easily find out what is the value of I2. So minus 3 minus 2 is going to be 5 times I2. So here 5 times I2. So it will 5 times I2. I think you understand this is minus 5 times I2 plus 17. Plus 17 is equal to 0. So how do you find out I2? How to find I2? Bring this minus 5 I2 to the other side. So you will get 5 times I2 is equal to 17. So 5 times I2 is equal to 17. So now you can very easily find out I2. I2 is equal to 17 by 5. So what is I2? I2 is equal to 17 by 5, which is nothing but, let me use my calculator. So it is 3.4 amperes. So this is the value of the current. So what is new in this circuit? What is new in this circuit is, this is the first time that you are solving a circuit with two sources. Here we have a practical voltage. Here we have a practical current source and there is also voltage source. So how to easily solve this circuit? Convert this current source into a voltage source. Then you will have only you converted this circuit into this circuit. Now it is very easy to solve. So just by applying Ohm's law or Kirchhoff's current law, Kirchhoff's voltage law, in fact, sorry, we can apply Kirchhoff's current law to this loop because we are having only one loop here. Once you convert it, we can very easily solve the source conversion. So again, let me rub this and let me show you how they have done in the book. So you can follow any method that you are convenient with. So the answer is the same. So it is 3.4. Now only thing that you have to be again and again you have to be very careful is the polarity. The polarity. What do you mean by the polarity? Why did you put the plus here? Because the current source, the arrow is like this. So the head is pointing, head is always, remember the head corresponds to the plus sign. So this is how you have to do the source conversion. Now again here we have two sources. One is a voltage source, another one is a current source. So how to easily solve this circuit? How to easily solve this circuit is please convert this current source with a parallel resistance into a voltage source with a series resistance. So we have only one mesh, or we call this as a closed loop. We have only one closed loop, and again it is very easy to solve by applying Kirchhoff's voltage law. We can apply Kirchhoff's voltage law and we can start to move from this point and we can again come to this point. So here this is 2 ohms, 24 it is given. How did you get this as 9? This is because 3 into 3 is 9. So how do you determine the voltage? Voltage is nothing but the product of the current and the resistance. 3 into 3 is 9. And what is this R2? R2 is nothing but the resistance in parallel will become resistance in series. So now let us apply Kirchhoff's current law. So what is the current in this circuit? Again you can see it is flowing in this direction. So this point becomes plus, this point becomes plus, this point becomes minus. So this point will become plus and this point will become minus. And this plus and minus is already given there in the circuit. So what about the voltage? We'll start from this node and apply Kirchhoff's voltage law. So it is a drop. So what is a drop? Minus 2 times I. Go to the next component. What is the next component? Minus to plus. It is a rise. So plus 24. So go to the next component. It is a source, so it is plus to minus, so minus 9. Go to the next component, so it is plus to minus drop. So what is a drop? Minus 3 times I. Go to the next component, which is R3. So this is again we are moving from plus to minus. So this is 7 times I is equal to 0. So what we can do? What is 24 minus 9? 24 minus 9 is 15. So we will keep 15 this side and 15. Okay, what about this 7, 10, 12? So minus 12i. So minus 12i is equal to 0. So from this you can solve and find the current. So what is our current? Current is nothing but 15 by 12. Current is nothing but 15 by 12. So what is 15 by 12? So it is 1.25 amperes. So what is the current which flows through resistance R3 or the 7 ohms resistor? It is 1.25 volts because all these elements are connected in series. The current is the same. So what is the current? 1.25 amperes. So this is the current. So what is the voltage across the 7 ohm resistor? This is what is asked in the question. So what is the voltage across the 7 ohm resistor? It is the current in the resistor, 1.25 multiplied by the resistance. What is the resistance? 7. So what is 1.25 into 7? 1.25 into 7. So 1.25 into 7, which is 8.75 volts. So this is our answer. So 8.75. So this is how you solve the circuit. Now, why did you convert the current source into a voltage source? Because this will make our job easy. So we will get only one closed loop. If you try to convert the voltage source into a current source, then it will make our job difficult. So we do the source conversion to make our job very easy to do it. So let us check how they have done in the book. So let me rub all these things and let me show you what they have done in the book. Yeah, I think their answer is matching with our answer. So you can find that their answer that they get 8.75 is matching with our answer. So the easiest way to solve this problem is to apply Kirchhoff's voltage law. So you will very easily solve this problem. So now we are coming to current sources in parallel. Now here you see there are two current sources connected in parallel. This 6 ampere source and this 10 ampere source are connected in parallel. Now what we can do is we can convert these two sources into a single source. Now how do you convert? Very simple. Just we have to add them or subtract them depending on their direction. So first thing that you have to do is sum. Add all the currents in one direction. Then add the current in the opposite direction and find their difference. And this is how to do it. But here it is very easy. 6 amperes is flowing from bottom to top. And 10 amperes is flowing from top to bottom. So what will be, so you find their direction of the current is different. So here we have to subtract. And how do you determine? We have to find out which of these two current sources have a high magnitude, whether 6 is bigger or 10 is bigger. 10 is bigger, so we have to use the arrow mark similar to what is available in 10. So here 4 amperes. So how did you get this 4 amperes? 4 ampere is nothing but 10 minus 6. The difference between this 10 ampere source and 6 ampere source. And why are you putting the arrow mark down? We are putting the arrow mark down because you compare the 10 ampere and 6 ampere. 10 ampere is a bigger current source than the 6 ampere. So we have to follow the arrow mark related to 10 amperes. Now the question is, how did you get this as 2 ohms? You find this resistance R1 and R2 are connected in parallel. So what is their equivalent resistance? Equivalent resistance means two resistance connected in parallel. So product of their resistance, which is 18. And the sum of the resistance is 9. So 18 divided by 9 is 2. So again I repeat, when you have multiple current sources connected in parallel, we can convert it into a single current source. How do you convert? First we have to determine the direction. We have to find whether the currents are in the same or different direction. Now in this case the currents are in different direction, so we have to subtract. And why did I put this current source downwards? Because it corresponds, you compare 6 and 10, which is greater. 10 is greater than 6, so we have to follow the arrow mark related to the 10 amperes. Now how did you get this resistance RP? You got this resistance RP because you know that R1 and R2 are connected in parallel. So when two resistance are connected in parallel, it is not the equivalent resistance is the product of the resistance divided by the sum of the resistance. So 18 divided by 9 is 2 ohms. Now let us solve this problem. So the first step is you find that there are three current sources in this circuit. 7 ampere and 4 ampere are in the same direction. So what happens? The total current flowing upwards is 11 amperes. And what about the 3 ampere current? The 3 ampere current is flowing downwards. 3 ampere current is flowing downwards. So here you find that first I converted 7 and 4 into one current source with 4 ohms. So this is in the circuit. So let me draw this one. This is 4 and this is 3. So what did I do here? First I converted 7 and 4. I found that they are in the same direction. So I add them and I put the arrow mark upwards. Then the next step what I'm going to do, I find this 11 amperes and 3 amperes are in different directions. So we have to subtract. So 11 minus 3 is 8 amperes. Very good, you found out. But what about the direction of the current? So the direction of the current is, you have to compare 11 ampere and 3 ampere. Which is bigger? 11 ampere is bigger than 3 ampere. So we have to use this sign here. So we have to use the same direction of the 11 ampere source. So this is how you solve the problem in current sources in parallel circuit. So let us do a problem here. Now in this question, you find that there is a voltage source series resistance and there is a current source with a parallel resistance. So what we can do, we can convert this voltage source with series resistance into a current source with a parallel resistance. So here we are converting this source. Here this source is converted into this source. So this is what we are doing here. So how do you find this current? So 32 divided by 8 is 4 ampere. So you can find here this is. How do you find the direction? The positive sign corresponds to the head of the arrow. Now here once you do the conversion, you find that these two current sources are in parallel and in the same direction. So what you can do, you can combine and make it into one current source which is 10 amperes. Now what about the resistance? How did you get this resistance as 6 ohms? Because this 8 ohm resistor and 24 ohm resistors are connected in parallel. So 8 into 24 divided by 8 plus 24 is 6 ohms. And then this is 14 amperes. Now in the question they are asking you to find what is the load current. How do you find the load current? There are two resistors connected in parallel and the current coming towards those two resistors is 10 amperes. There are two ways in which you can solve. You can apply the current division rule or you can apply the special formula. So how do you find IL? IL is equal to the total current coming towards the parallel resistor, which is 10, multiplied by the other branch resistance. What is the other branch resistance? 6, divided by the sum of the resistance, which is 6 plus 14. So this is how you have to find it. We are using the special formula to find the current through the load. So 10 into 6 is 60 and 6 plus 14 is 20. So 16 divided by 20 is 3 amperes and 3 amperes is the current which flows through the load. Now here when we convert this voltage source into a current source, this makes our job very easy. So this is how you do a problem with multiple sources. Now the question is, can we connect two current sources in series? The answer is no. Two current sources of different ratings, 6 ampere and 7 ampere, you cannot connect them. So this is not possible. So current sources of different current ratings are not connected in series. So this is invalid. You cannot do this. So these are the homework problems. I hope if you understand this presentation, you can easily solve them. So please try them. So thank you so much.